Hello students, welcome to part 2 of linear programming. So before we move on to this video, so this is part of our SEM marathon. We are covering each and every topic with conceptual clarity. Right, so now we will move to linear programming part 2, that is solution methods. In part 1 we have covered the formulation part. Now we are moving to the solution methods. Now we have two methods. One is graphical method, the other one is simplex method. The first one is graphical method, the second one is simplex method here. Now when we can apply this graphical method is whenever in our objective function we have two variables. When we have two variables, then you can use graphical method to get the optimum solution. Now if you have more than two variables, so if you have more constraints, more variables, then we should use simplex method. So if you see at final level, what is expected is solutions only, not just formulation. Of course formulation is required for solution, but mostly what they should cover at final level is, that is solution. So far they have not asked, but I am expecting for coming attempts. So I advise you to be perfect in this particular concepts, that is solution methods, graphical method and simplex method. Then you can bank on this particular topic. I am very sure that in this attempt, coming attempt December 25, they are going to cover solution methods. Definitely they are going to ask you solution. Right. So first let us cover graphical method now. So graphical method is very easy. It's not at all difficult. And when we should apply this graphical method is only when we have two variables. Only when we have two variables. You can have number of constraints, but I'm talking about only number of decision variables what I'm talking about. So if you have only two, then you can use graphical method. So let's focus on graphical method now. So what are the steps involved in order to achieve the solution under graphical method? The first one is step number 1. First you need to formulate LPP, objective function, constraints, non-negativity, assumption, either for maximization or minimization. So formulation is the first thing again here also. Step number 2 is, now here our work starts in graphical method. So what we have to do under step number 2 is, every constraint in equations that should be converted into equations equal to 0. Then we need to plot these equations in the form of lines in our graph. So to do that we require coordinates. Yes, we require two coordinates in order to form a line. Okay, one starting, one ending, we require coordinates. Yes, for every equation you require coordinates. So first what you need to do is, any equation whether greater than or less than, first you need to convert into an equality, that is equal condition, that is you should equate with 0. If you equate with 0, then we can get the coordinates. How we can get the coordinates here is, see here in this example, one constraint is there, 6x plus y greater than or equal to 18. This is the constraint. Now this we should equate with 18 here, it is 18 here. So equality you should create here. First thing is you have to create equality. So 6x plus y is equal to 18. Now to get the coordinates, what you should do is, first take x is equal to 0. Then substitute in this equation. If you put x is equal to 0 here, this will become 0. So y is equal to 18. Okay, so now you got a coordinate, first coordinate, that is 0, 18, x, y. Then next again take y is equal to 0 first. Then if you put y is equal to 0 here, then x you will get 18 divided by 6, 3 you will get. So x3 y is equal to 0. So this is how you should get the coordinates for every equation. So step number 2 is we should represent our inequations on the graph. To represent or to depict on the graph, we require coordinates. So how to get the coordinates is first convert the inequality into equality. Okay, then take first, to get the coordinates we should take first x is equal to 0, then you will get the other variable. Then take y is equal to 0, then you will get the other variable, x variable. So this is how you should get the coordinates. Then plot these coordinates on the graph. Okay, here when you are plotting your x1, x2, whatever you assume variables, both are greater than 0 only, greater than or equal to 0, non-negativity assumptions, no. So whenever we take here, formulate the LPP, we always write our decision variables greater than or equal to 0. So generally in the graph, it will fall in the first quadrant only. Right, plot the points, then draw the lines. Then after doing that, you should identify the common feasible area. What is common feasible area is by satisfying all the equations. What is that common feasible area you have to find out? So practically we will understand that. So if you have one equation greater than, then greater than. If you have one equation less than, then draw shades towards the origin. So like this, all equations conditions we should satisfy. So what is that area which satisfies all the equations? That is what we have to find out, which we call it as common feasible region or solution space. So that is, it is the area which satisfies all the inequations simultaneously. Once you do that, once you find out the common feasible area, then in that common feasible area we should identify the corner points of feasible region. So how to identify the corner points also we are going to cover in our example. Then once you get the corner points, then take those corner points and substitute in the objective function. Those for each corner point, the x value and y value, substitute in objective function, you will get the value of objective function. Now if your objective function is maximized, out of the values whatever you got in the objective function, that is objective function values, by substituting the corner points, out of that highest value you should consider if your objective is maximization. If your objective is minimization, out of that least value you should consider. So these are the steps. So let's understand this with the help of an example. Let's take your CMA material question only. So let us take one question here. In this, already while doing formulation, this we have done. If you remember, formulation already we have done for this in our first part. Okay. Now this one we have to solve by graphical method. Solve graphically, they have given, you can see. So once again quickly we will take this one. We will read this question, then we will see what are the conditions given here. So here they want to make cakes here. One kind of cake requires 200 grams, 200 grams of flour and 25 grams of fat, and another kind of cake requires 100 grams of flour and 50 grams of fat. Find the maximum number of cakes that can be made. So number of cakes here. So two different types of cakes we have to make here. So how many we have to make of each category? Can be made from 5 kgs of flour and 1 kg of fat. So what is the quantity available maximum? Flour is 5 kg, nothing but 5000 grams, and fat is 1 kg, that is 1000 grams. There is no shortage of other ingredients required for making the cakes. So only these are the two constraints we have. Formulate LPP based on information given and solve graphically. So already here analysis first. So two cakes here, T1, T2, and what are the inputs required? Flour and fat. What is the quantity required for each cake? We have written here 200 grams, 100 grams here, fat 25 grams, 50 grams, and what is the max available? 5000, 1000. So now let us assume this number of cakes of T1 as x1, t2 as x2, or you can take it as x comma y also here. So now what will be the objective here? To make the maximum number of cakes here out of this input. So what is the objective function, and what is the objective function here? Maximize z is equal to x plus y or x1 plus x2. Right, so that is the objective function. And what are the constraints here? Constraints are, one is floor, the other one is fat. So how to represent this is number of units multiplied by the quantity required. So 200x plus 100y must be less than or equal to 5000 grams, because you cannot consume more than 5000 grams. Similarly, fat 25x plus 50y less than or equal to 1000 grams. So this is our constraints, and here x comma y must be greater than or equal to 0. They should not be negative, they should be 0. They should be greater than or equal to 0. So if you represent them now, so these are the equations: max z, floor, fat. These are the subject constraints here. We have written non-negativity assumption. Now what we should do is, we should convert this inequations into equations, equality, and then find out the coordinates for each one of it. So if you find out coordinates now, illustration number 3, what are the coordinates now? For each one we have to take illustration number 3, ICA material. Now this is maximization or minimization? Minimization. First LPP we should take. LPP, maximize z is equal to x plus y. Okay, so we are assuming let x comma y be the number of cakes of type 1 and 2 respectively. Okay, this is the objective function. Now conditions are nothing but restrictions. Subject to what? First one, floor. So 200x1, 200x plus 100y. Less than or equal to 5000 grams. Next, fat. (25x plus 50y). 25x plus 50y less than or equal to 1000. And finally, non-negativity assumptions. Your x comma y must be greater than or equal to 0. Okay, now we will convert this inequalities into equalities to get the coordinates here. Next thing is coordinates for each equation. So if x is equal to 0, y is equal to 0, what are the coordinates we'll take? coordinates. What is the first equation now? 2x 200x 200x plus 100y is equal to 5000. Okay, I am substituting first x is equal to, if x is equal to 0, then y is equal to 5000 divided by 100. It will be 50. Y is equal to 50. If y is equal to 0, then 5000 divided by 200, what you will get? 5000 divided by 200, 25. So what are the coordinates here is 0 comma 50, other one is 25 comma 0 for this particular equation constraint. Next one, 25x plus 50y is equal to 1000. First x is equal to 0, then 1000 divided by 50. So it is 20. Next, y is equal to 20, then y is equal to 0. If y is equal to 0, then x is equal to 1000 divided by 25. So it will be 40. So what are the coordinates here? 0 comma 20, other one is 40 comma 0, and other one is x is equal to 0, y is equal to 0. Even those also we need to, even non-negativity also we should plot. Right now graph we have to take. We have to take the graph here. Scale also properly you should draw here. So let us draw the graph now. X-axis, this is, we require up to 40. So this is our x-axis, this is our y-axis. In fact, if you use graph, then that will give you a proper picture. Exact values we are going to get. So here what we can do here is, I will introduce graph here, so that exactly, because our answer depends on the corner points only. So in my note I don't have the graph here, so let's use this only. So now what we will do is we will give the scale first. So x, we are starting from 0, it can go up to even 40 also, because x is equal to 40 now. So what we can do is 10, this is 10, this one 10 10 we will take 10 20 30, this is 40. Here also the same, we will take 10 10. We have to go up to 50, y is 50. So here exact will take, so this is 10 20 30 40 then 50. Right now first what we will do is each line, each equation we will represent in the form of a line. Now first one, this one. So first coordinate is 0 50, 0, this is 50, y is up to 50 now, yeah, 50. So 0 50 means this is the point, 0 50. Next one 25 0, 25 0 means here exactly middle. So now we should draw a straight line. Now which one, this equation whatever we have done is 2x plus 200x plus 100y is, this one is 200x plus 100y is equal to 5000, that one, this equation represents that. This one is 200x plus 100y greater than or equal to 100, greater than or equal to, not greater than, less than or equal to 5000. That equation we are trying to represent. Okay, next one is second equation 0 20, 0 20, this is next one. 40 0, this one, right? So now we have to join these two points. Yes, this is your 25x plus 50y less than or equal to 1000 equation. Right now what we have to do is we have to satisfy the conditions of the equations. What is that now? We have to find out the common feasible area. Now first equation, both are in fact less than only, no? Both are less than only. So that means those should be drawn towards the origin. So if I draw now roughly, everything is towards the origin only. So if I take, everything is towards the origin only, no? So what is that common feasible area means? Even second equation is also less than 0, no? So this one is also less than. So which area which satisfy, what is the common area for both now? Is this one only common area? Both are less than only, no? So what is that common area is? This is the common area. So this is the common area for both. Up to here only. It will satisfy both the equations. Okay, now this is a common feasible area. Now what we have to do is, this is the common feasible area. That means it will satisfy both the equations. Less than only, no. Now corner points up to here only. Corner points we have to identify now. In this common feasible area, what are the corner points? This is one corner. This is one corner. Okay, here it is another corner. Here it is. So we have 4 corner points. Obviously, one corner point here is the origin 0, 0. Okay, the remaining corner points is, so what are the corner points here? Corner points of common feasible area. Common feasible area. See, in examination, if you are unable to identify the points or corner points, you can solve the equations also. Even by solving equations also you can get. So corner points of common feasible area is 0, 0, anyhow it is there. Other corner points you can take. So first one is 0, 20. Next one. Yeah, now this is very important. Here see this one. This one and this one. So this is 20 comma 0. Other one is not 20 comma 0. It is 20. Exactly this one. No. So that is 20, 10. Third one is, if you see here, no, it is so what is that point here? This one, this particular point we have to identify. So what is that? Is 25 comma, exactly it is falling between 20 and 30. It is 25 comma 0. So these are the 3 corner points. Other one is obviously 0, 0. So 4 we got corner points here. Okay, now what we have to do is, these corner points we have to substitute in the objective function. So objective value now, for each one if you take, what is our object? X plus y, z is equal to x plus y, no, z is equal to x plus y. So first if you take 0, 0, obviously you will get 0 only. The second one what we will get? 0 comma 20, if you take 0 plus 20, 20. Okay, if you take 20 comma 10, 20 plus 10 is equal to 30, you will get. 25 comma 0, if you take 25 plus 0, you will get 25. So out of this, highest is 30. So that means what? You are getting maximum for this two only, 20 and 10. So that means you should produce 20 units of X and 20 units, 20 cakes of type 1 and 10 cakes of type 2. So answer is 20, 10. So 20 and 10. These are the two numbers of type 1 and type 2 respectively. So this is graphical method. If it is minimization, then what we will do? Out of the values, whatever we got objective values, out of that least you will consider. So this is your graphical method. So let's see here. You can see their graph here exactly. So what are the corner points? 25 comma 0, 20, 10, 0, 20. So you can see. So it is clear from the above value that Z is the maximum at point 20 comma 10. So thus the solution of LPP is given as Z max is equal to 30 and the corresponding values of the decision variables, that is x1 and x2, or x comma y is 20 and 10. So in other words, the maximum number of cakes to be made is 30, and this is achieved by making 20 numbers of first type and 10 numbers of second type. So this is your graphical method. So objective value you should take higher in case of maximization and lower in case of minimization. Alright, so this is your graphical method. Now when your common feasible area is on the top part, see here, if this is the common feasible area upwards away from origin, then generally it is called as an unbounded solution. The reason is the value objective function value can be higher one. If it is showing upwards means we will not get corner point for upward. No, that is called as unbounded solution, right? So this is your graphical method. So graphical method is a simple one, but graphical method will help you to understand simplex method. That is the advantage of learning graphical method. So I hope everyone understood graphical method. This is your graphical method. Now let us move to simplex method. Okay, now let us move to simplex method. So most of the people feel little complicated this one, but if you put some efforts, easily you can understand. So when you should apply this simplex method is when you have more than two variables. Whenever you have more than two variables, we have to use this simplex method. So under simplex method, what are the steps involved here? Step number 1 is first, as usual, objective function you should write, either maximization or minimization. Then you should write the constraints also. Here when you are writing constraints, okay, there are some additional things to be done. That is, generally when you are writing constraints, that is, you have to state this in a standard form. For using simplex method, there is a standard form of representing the equation. So what is that? Let us see here. Constraints. List the constraints applicable for the objective. For maximization, at least one constraint should bear less than sign, less than or equal to sign. So constraints when you are taking, if it is a maximization, generally less than we will have no constraints sign, at least one you should have. For minimization, at least one constraint should bear greater than or equal to sign. Now step number 3 is we should convert inequalities into equalities, like in graph we have done. Here also we have to do that, but there is a standard form here. So what is that? Is when you have constraints of less than or equal to, when you have constraints less than or equal to, a slack variable is introduced. What is introduced? A slack variable. Slack variable generally meaning is unutilized resource, that is idle resource. Slack variable means. So where we should introduce this is in the constraint equation we should introduce. Even in the objective function also we should take this, because when you are taking in the constraints any variable, naturally it should appear in the objective function also. Yes. So what exactly is slack variable? Now if you want to convert an equation into equality, okay, say for example, now earlier case only, so you had this 200x plus 100y less than or equal to 5000. Okay, now actually if it is greater than, then what we should do? Less than first, less than or equal to case. then what we should do here is, now we should convert into equality. 200x plus 100y is equal to 5000. So if you want to convert into equality, what will happen is, actually these two put together will be less than 5000, no? So now if I cannot equal directly, I cannot equate with 5000, because as per the constraint here, both put together must be less than or equal to 5000 only. Less than or equal to 5000. Now if you want to convert into an equal to condition, that is equal to 5000, then what will happen here is, what is the problem here is, a less than sign if you want to convert into equality here. So what might happen is, if you take these values, okay, those values are less than 5000, no? If you now take according to the condition here, first original constraint, it is less than type. That means x plus y both together must use less than 5000 only, no? So how it can be equal to 5000? If you want to convert into equal to 5000, that means we should take a variable as ideal variable. Then only you can make equal to what? 5000. I hope you are getting my point. Why we should take this slack variable is, actually this condition is less than, these two put together must be less than what? 5000. But if you want to make it equal to 5000, then what we are supposed to take is an ideal. We should take that there is an ideal resource. Then only I can make this equal to what? Equal to, then only I can use. So what I should do is, I should introduce a variable called as slack. Slack means unutilized. Then only this equal to condition will get satisfied. Otherwise it will not get satisfied. So to make it equal only, we are using this slack variable. This slack variable will have a coefficient before that 1. Whereas in the objective function also we should introduce this variable or not. There the coefficient will be 0, because ideal resource will not contribute. If there is any resource ideal, that will not give you any output, no. That is the reason in the objective function the coefficient of this variable will be 0. I hope you understood why slack variable should be introduced here. So whenever you have a less than or equal to constraint, now if you want to convert into equality, then we should introduce a slack variable, so that equal to condition will get satisfied, right? So slack variable should be positive only. So 0 for all slack variables. What is this 0 is, in the objective function the coefficient should be 0, okay, whereas in the constraint the coefficient will be 1. I hope you understood why we should take slack variable. If you take slack variable, then the equal to condition will get satisfied, because earlier it was less than. Now if I have to say it is equal to 5000 means, that means we have to add something there, so that it will become equal to what? 5000. At least that mathematical thing you should know. If you add something, then only it will become equal to, no, earlier it was less than figure. See, earlier 470, so less than what? 500. Now if you have to make equal to 500 means what I should do? 30 I should add or not? Yes, 30 quantity I should add or not? Yes. So that 30 only I am taking as now ideal. Okay, I am assuming that it is what? Ideal. Then only it will become equal to. So that is slack variable. So when you should introduce slack variable? Whenever you have less than or equal to constraint, and if you want to convert into equality, then we should use slack variable. Yes. And the slack variable obviously should be featured in objective function also. So there the coefficient of this variable will be 0. Whereas in the objective function we are adding, no. So there it will be 1. Okay, next thing is, concentrate now, greater than type. If we have any equation, then greater than we have to make equal to, no. That means something we have to deduct. We have to deduct or not? Yes. So that again become equal to, not add, this is deduct. So that is only called a surplus variable. This time we are assuming that we have surplus. So that must be deducted in the constraint, surplus variable. Okay. Surplus variable, what we should do? We should deduct. Now, apart from this, we should also introduce one more variable called as artificial variable. Why this artificial variable is, when you are getting simplex method solution, we require a unit matrix for our variables. So if you take surplus variable coefficient will be minus 1. So minus 1 cannot be taken for a simplex method solution. So that is the reason what we do is we have to introduce artificial variable also. Right, in my regular class all these concepts are thoroughly explained, logic also, but here unfortunately we don't have sufficient time here. But now what you should know is, whenever you have greater than sign, then we have to use a surplus variable as well as artificial variable. Okay, surplus variable should be deducted, whereas artificial variable should be added there. So whereas, because these are two additional variables we are introducing, again these should appear in objective function also. Yes. So objective function, surplus variable will have coefficient 0, whereas artificial variable, because it has got no meaning at all. So what we should do is, this in our final optimum solution should not appear. So that is the reason we should eliminate this. In order to eliminate this we will consider as a penalty. Okay, so that is the reason if you have a minimization objective, then what we will do is we will add to the objective function. Whereas in case of maximization objective, the coefficient will be minus m. So m is the coefficient of the artificial variable coefficient will be m. M represents here a penalty here, infinity cost basically. So why we are taking infinity cost is, so in our simplex method solution we take artificial variables. Why we take artificial variable rather than surplus variable? Surplus variable if I take, I will get minus symbol. Our quantity cannot be, final quantity cannot be negative, no. So that is the reason what we do is we use artificial variables, and artificial variable means nothing, no. So that is the reason we have to eliminate this. To eliminate this, we should make sure that this is the highest cost. So to take it as a highest cost, we take m. M represents the infinity cost. So if it is minimization cost, no, so we will add. If it is maximization, then we will deduct. So minus symbol will be there. Okay, so when we convert a problem, then you will know the meaning of this. So whenever you have greater than sign, we should introduce both surplus variable as well as artificial variable. But if you have only equal to sign, then only if you introduce artificial variable, that would be sufficient. M represents infinity cost or penalty. So first, step number 1 is, first we should take objective functions, next one constraints we should write. Now constraints we should convert them into equality. So whenever you are converting them in equations into equalities, if you have less than or equal to type, then we should introduce a slack variable. If you have greater than or equal to, then we should introduce both surplus variable as well as artificial variable. And what are the coefficients in the objective function is, surplus variable and artificial will have 0, whereas surplus variable as well as slack variable both will have 0 as coefficients in the objective function, whereas artificial variable will have m. If it is minimization, then plus m. If it is maximization, minus m. So this is conversion part only. Then initial simplex table. This is the format of the simplex table. Okay, so what we take here is program variable. So first we should take which one? We should start with which variables? We call them as program variables. Every program variable will have a coefficient before that. Yes, that coefficient could be profit or cost. Those we should take here in this column. Quantity represents here. Every constraint will have quantity. Yes, that we should take here in the quantity column. Then these are variable columns. Every variable will have coefficients, that we should take here. What is replacement ratio? What is the purpose of that? I will tell you. Next, Z represents the coefficients of the objective function here. Z is nothing but the coefficients. It could be contribution per unit or profit per unit in our objective function. No. So that we will take here. Alright, C is the computed value. Computed value is nothing. How we are going to get computed value? Then next one, NER. NER is Z minus C. So each one you should understand here. Okay, so what we will do is, this is the table format what we have to use. So what I am going to do is, I am going to take a problem, okay, and do it for you, so that you will also understand. All these points I have written. Just quickly I will go through all this. Those who know this, a quick revision will happen. So this is the format what we use for doing simplex method. Just you have to know this. Program variables are nothing but the variables what we start with, and the coefficients of that we should take here. And constraints are right hand side quantities there, no, that you should consider here. Then here in this we should take the, that is constraints coefficients here. So what is replacement ratio? I will tell you. Next one, Z represents the coefficients of objective function here. Z represents what? Coefficients of objective function. Then C represents a computed value or profit lost per unit. How to get this C value is, this profit or cost per unit we should multiply with this variables. This, if you should multiply with variables and get the sum, then you should get NER. NER represents Z minus C. Okay, yes. Now what you do is, just look at this solution of simplex method. We will take up one question, we will try to solve. Along with that I will explain each point here, so that you will understand in a better manner. Okay, let's take one question now to solve simplex method. We will take instrument metal question only. So you have to write in a standard form. So let us use this question now. Illustration number 6 is your simplex method only. Illustration number 6. A firm manufactures and sells two products, alpha and beta. Each unit of alpha requires 1 hour of machining and 2 hours of skilled labor. Okay, machining 1 hour required, skilled labor 2 hours, whereas beta uses 2 hours of machining and 1 hour of labor. For the coming month, the machine capacity is limited to 720 machine hours and skilled labor is limited to 780 hours, not more than that. Not more than 320 units of alpha can be sold in the market during a month. So alpha, how many you can sell in the market? Maximum is 320, not more than 320. What about beta here? Beta they have not given, only they have given alpha. Develop a suitable model that will enable determination of optimal product mix. So suitable model they have given here. See how many conditions are there here. Okay, we have let us write now, analyze this now. First you analyze this. Okay. What are the products? Products are alpha and beta. Machining, how many hours are required? 1 hour. Skilled labor, 2 hours are required. Okay, what else is given? Contribution per hour is also given. What is the contribution per hour? 6 rupees. This is contribution per unit here, alpha. Beta contribution is 4. And what is the maximum machining hours available? 720, 780. So what we have to determine here is, we have to find out the maximum, we have to maximize here. So how we can write here, what we have to find out? What are the variables here? That is how many units of alpha and beta we have to make. Those are the decision variables, alpha and beta. So you can assume it as x1 and x2 here. X1 and x2 be the number of units of alpha and beta. And then what do you need to here maximize? The contribution you should maximize. So what is the objective function here for this? We will write in our style. Illustration number 6 for this. Here, slack variable, surplus variable, artificial variable. These are the 3 things we should know if you want to solve simplex method, because inequality into equality, if you want to convert, then we have to use this. So illustration number 6. What is given here? Analysis first we will take. Alpha and beta. These are the 2 products. Machining, how many hours are required? One hour. Beta requires 2 hours. 1 hour, this is 2 hours. Other one is labor. Labor time 2 hours and 1 hour. And what is the max mission time? What is the maximum time available here is 720 hours. Labor 780. So here, apart from this, what else they have given here is, what is the contribution per unit? What is the contribution per unit they have given is 6 and 4 in the question. You see in the question here what they have given is, determine the optimal product mix. Optimal product mix means how many units of alpha and beta to get the maximum contribution if unit contribution from alpha is 6 and beta is 4. So objective is maximization. So now how many units of alpha and beta we should take? Now let us assume now this as x1. So decision variables is, we will assume this as x1, this one as x2. Okay, this one is x1, this one is x2. What is the one more condition we have is, alpha how many we should produce? One more condition is, not more than 320 units of alpha we should produce. So it should be less than or equal to 320. So let us write now, what is the objective? So we are assuming let x1 comma x2 be the number of units of alpha and beta. So now if you LPP, if you see first objective function, maximize z is equal to, what is the contribution, 6x1 plus 4x2. Okay, I'm just writing first objective function because that is what is required now. Subject to first one, machining. x1 plus 2x2 must be less than or equal to 720. Then labor 2x1 plus 1x2 less than or equal to 780. Okay, one more condition is alpha, that is alpha minimum, x1 less than or equal to, or greater than or equal, not more than he gave, no, so less than or equal to not more than 320 units of alpha. So these are the constraints. How many constraints we have? 3 constraints we have. So whenever we have 3 constraints, you cannot use graphical method. So no, not constraints here, sorry, variables. Hello, here variables here. How many variables are there? x1, x2. Only 2 variables are there, no? So you can use either graphical method or simplex method also. For this graphical method you can use. Instead of simplex method you can use graphical method for this. Okay. But here just for the sake of explaining I am using this. Whether they don't know whether they use this graphical method. Simplex method only they used here. So we will also use simplex method for your understanding purpose here. Actually for this we can use graphical method. We have only 2 variables now. Now we have to convert this into equality standard form. We should express this in standard form. Which one? These constraints we should convert this in standard form. Since we have less than or equal to type, we should introduce slack variables. Okay. How many slack variables we have? 3 now here. In these 3 cases, 3 slack variables we should introduce. First one, to convert first equation, second equation and third equation into equal, we require 3 slack variables we require. Yes, let us assume those slack variables. Now to convert constraints into equality, less than or equal to constraints, that is to convert less than or equal to constraints into equality, we need to introduce slack variables. 3 slack variables because we have 3 constraints, less than or equal to constraints. 3 slack variables. So S1, S2, S3. This will be added, and in the objective function the coefficient of this slack variable will be 0. Slack means idle resources. No, so idle resources will not produce anything, that is the reason. So now maximize Z is equal to 6x1 plus 4x2 plus 0 S1 plus 0 S2 plus 0 S3. So this is how you should convert your objective function. Then constraints, this is the standard form. Subject to first constraint x1 plus 2x2 plus plus S1. You should add no. And remaining also you can show here. Remaining will have 0 just for representing them in the in our simplex table. We can show this. Take 0 coefficient for that. 0 S2, 0 S3. 0 S1 plus 0 S2 plus 0 S3 less than or equal to 720. Now we are converting into 720. Next, 2x1 plus x2 plus S2, no, slack variable 2 here. So now S1 will have 0. S2 plus 0 S3, 780. Third case, x1 plus 0 S1 plus 0 S2. See, if you don't have those elements, generally we take 0, no? Yes, that is what I am saying. 0 S2 plus S3 is equal to 320. And non-negativity assumptions, that is your x1, x2, x1, x2, S1, S2, S3 here greater than or equal to 0. So first you should write this in standard form. This is the standard form for simplex table. This is a standard form. Now only slack variables are required here. Right, if it is greater than or equal to type, then what we should introduce? We should introduce surplus variable as well as artificial variable. That one more problem we will do. Now in simplex table, first what we should do is we should set up simplex table. Simplex table, what we are supposed to take. This is the format now. Program variables first we should take. Program variables. Then what is the coefficients of those program variables in the objective function? Profit. Then we should take the quantities. Then we take the decision variables. You can see the format here. Then we take the variable columns. Decision variables. What are the decision variables we have? What are the variables we have? How many variables we have? Now 5, along with slack. X1, X2, S1, S2, S3. Okay. First what we should do is, this is what very important. First we will assume that to get the optimum solution, the first point we will take it as a corner point. In our common feasible area, what we do is, we start with one corner point. Then if you don't achieve optimal solution there, then you will go to the next corner point. So in simplex method, that is what happens. That is the thinking. So first corner point, usually what we start with in our simplex method is 0, 0. For the variables, we assume that our decision variables is 0. The quantity is 0. So here x1, x2 we will assume it as 0. That is the first, what do you call, the variables assumption, value should assumption. I mean, that is the value you should consider. x1, x2 first we will assume it as, what if x1, x2 is 0, then what is the value of s1, s2 and s3? If your value of x1, x2 is, if you take x1, x2 as 0, then what will be your s1, s2, s3? So that is what I have written here. First, what you should do here is select slack variables as initial program for maximization. Select slack variables as initial program for maximization. So we should take slack variables as the program variables. What is the logic for that is, first we will assume our x1, x2 be 0, 0. The number of units of x1 and x2 as what? 0, 0. Then in that case, then what will be the value of s1, s2, s3? Okay, what will be the value of s1, s2, s3? That we have to find out. Select slack variable as initial program for maximization. In case of minimization objective, slack and artificial variables constitute the initial programming, forming a unit matrix of the coefficients. So first what we should take here is, we should assume that our x1 and x2 is 0 units. So if you assume them as 0, then what will be the value of s1, s2, s3? Take the equations only here, our example. So in these equations, if you take x1, x2, 0 in this, then tell me what will be the value on the right hand side? Here only now, x1, x2, if I take 0, what will be the value of s1? Anyhow, this is 0 only now. s1 is equal to what you will get? 0 only will get. Yes. So I am introducing s1. Because if I take x1 is equal, x1, x2, 0, in the first equation, how many equations we will have? 3 equations, 3 rows we will have. s1, what is the answer here? Quantity you are getting? 0. Sorry, not here, here. What is the profit you will get? 0 you will get. S2, 0. S3, 0. Okay. So what I am asking you to do is, if you take x1, x2, 0, naturally S is a slack variable, no? S1, S2, S3 are slack variables, they will not produce any units. So that is the reason 0 will be their coefficients. These coefficients are zeros. So you can also see in their solution now, they must have taken S1, S2, S3 only, you can see. S1, S2, S3, and what is the coefficients of that? I mean, the values of that? Zeros. Profit per unit of basic variable column. So what will be the profit per unit if you take program variables as S1, S2, S3? So what is program variable? That you should understand. What is the meaning of program variable is? First we are going to start assuming that our x1, x2 is equal to 0. Then if x1, x2 is only 0 units, obviously s1, s2, s3 will give you what? 0 only. So that is what I have taken. Profit per unit of the basic variables. S1, S2, S3 profit will be 0 if you produce x1, x2 as what? 0. Number of units is 0. Okay. So that is what I have taken. So what is the second column is profit per unit of the program variables. This variable's profit, this is. Now what is the quantity of each of these rows we should take? Here we should take quantity, means quantity represents the right hand side quantities here. So first equation, right hand side quantities 720. Here it is 780, second one. Third one is 320. So what you should fill up here? Right hand side, constraints right hand side you should fill up. So this is what first I have written here. Step number table, no. Program variable, profit I have taken, quantity I have taken. So let us understand this. Select slack variables as initial program for the maximization. Okay, now we are doing maximization problem only, no? Yes, so we have selected slack variables only, initial program variables. Okay, then fill up profit or cost of the program variable as per the objective function. So in the objective function, what is the value of this program variables? Program variable S1, S2, S3, what is the value in the objective function? Nothing but the profit. Profit will be 0 only, no? Yes, that is what I have taken. So that logic only I was explaining. If you take x1, x2 as 0 units, then what is the value of s1, s2, s3 will be 0 only. So directly objective function coefficients of the slack variable s1, s2, s3, that only you should take it as profit. Okay. Then fill up the quantity column. Quantity column, what you should take? Right hand side of the constraints. Constraints right hand side you should take. Then next thing is fill up the coefficients of various variables as per the constraints in the respective columns. Yes, now we will take 3 rows we have taken over here. S1, S2, S3. 3 slack variables we have taken. Now what we should do is, this is first constraint quantity, first constraint. So that equations variables, we have x1, x2, s1, s2, s3. These variables coefficients we should take in the equation. So here x1 coefficient is 1, x2 coefficient is 2, here it is 2, s1 coefficient is 1, s2 coefficient is 0, s3 coefficient is also 0. Second equation we can consider a second row. x1 2, x2 is 1, s1 0 because s1 is not there in that, so 0, s2 is there, so 1, s3 is not there, no, so 0. Then third one, 1 0 0 0 1. So these are the coefficients of the 3 constraints we have taken. Okay, so this is what first you should take. First what you should do? Now if you see here, we should get a matrix, unit matrix we should get 1 0 0 0 1 0 0 0 1. For slack variables you should get what? Matrix here. Whenever you are preparing initial simplex table, make sure that in the initial simplex table you have the unit matrix. So if I take here S1, S2, S3, then only I will get unit matrix here. If I take S1, S2, S3, then only I will get unit matrix here. If I take directly X1, X2, I will not get unit matrix for the initial simplex table. Okay, that is step. But what is the logic behind that? I told you. What is the logic is, first initial simplex table we will prepare assuming that the number of units of x1 and x2 is 0. If number of units of x1, x2 is 0, naturally the values of s1, s2, s3 is also what? 0. Okay. Right. After this, you should calculate here z value here. Z is nothing but we should take here z. What we should take? Objective values we should take. Objective function, whatever is the value of these coefficients x1, x2, x1, s2, s3. The coefficients of this we should take as z values. Nothing but objective values, these all are objective function values of these variables. X1 in the objective function, what is the coefficient? 6. X2 4 in the objective function. S1 0, S2 0, S3 0. So what I have taken here, z value represents the coefficients of the variables in the objective function. Okay, this you calculate, this you take now. After this, next thing what you should do is, you should calculate C, computed value. C is computed value. What is this computed value is? what is the profit per unit if I produce 1 unit of x1, 1 unit of x2, 1 unit of s1, 1 unit of s2, 1 unit of s3, what is the profit? How to calculate this is, you should multiply this units with profit per unit, this column. How do you get computed value? This coefficients of the units, if I introduce these units, then what is the profit? That is what we are calculating. That is only called as computed value. So 0 into 1 plus 0 into 2 plus 0 into 1. If you add all this, that will be 0 only. Because you have 0, 0 here, everything will be 0 only. That means if you introduce 1 unit of x1, then what will be the value of x1? 1 unit of x1 if you introduce, what is the value? It will be 0. That is the meaning. Now, NE or net evaluation you should calculate. As per the next step is, we have calculated both now. Fill up the Z row we have done, that is objective values against each variable as per the objective function we have taken. Then compute C value. How do you get C value? Profit into coefficients of each variable. In the matrix, in the table, whatever we have coefficients of each of the variables, that we should multiply with profit. The sum of that we should take, summation of profit into coefficient. Now compute net evaluation row, NER, Z minus C. What is Z? Z is the contribution per unit. From that, what you are deducting? What would have been the profit had you introduced 1 unit of that? So N minus NER is nothing but Z minus C. So let us calculate Z minus C. Now NER you should calculate. NER, net evaluation. How do you get this? Is Z minus C. So Z value is 6. So 64000. Z minus C only we should do it here. We have done that. Z minus C. Z minus C. So ensure that program variables have 0 NER. So in this program variables x1, x2, we have 0. Program variables S1 not x1 not x1 x2. Here what are the program variables? S1 S2 S3. So S1 S2 S3 NER what we got? We got exactly 0 or not? Yes. Okay. Now what is the meaning of NER here is, if I introduce 1 unit of x1, then what will be the net profit per unit? Your profit will increase by 6 rupees per unit. If I introduce x2, then profit will increase by 4 rupees per unit here. So here we should stop and check for a condition. What is that condition here is, if it is maximization, then your NER values must be less than or equal to 0. If it is maximization objective, then your NER values must be less than or equal to 0. See here steps. Compute net evaluation row, NER is equal to Z minus C. Check whether NER is less than or equal to 0 for maximization. If your objective is maximization, what we should check is whether NER value is less than or equal to 0. If you see here, your solution, S1, S2, S3 it is 0, but for x1, x2 it is greater than 0, it is not less than 0. So that means the solution is not optimal. Since NER for x1 comma x2 is greater than 0, the solution is not optimal. Now what we should do is, we should we should introduce now the decision variables. Okay, which variable I should introduce now? Earlier we took x1 x2 as 0, no? Yes. Now what we should do is we should introduce our decision variables, either x1 or x2. So what if I introduce 1 unit of that, then how much my profit will increase? Let us do that now. So but the question is which one we should introduce? The question is which one we should introduce. For this there is a procedure. What is that procedure is, out of these NRE values, take the maximum positive value here. Which one? Maximum positive value. Which one is maximum positive value? 6. This we take it as key column. That means we are going to introduce x1 now. So to know out of this now x1, x2, which one we should introduce. Earlier x1, x2 we took it as 0 in the first table. Now since we did not get optimal solution, what we are supposed to do is, now we should replace one of those program variables with what? One of the decision variables, that is x1 or x2. So now which one we should do that? For that, NER is the basis. Out of NER values, whichever has higher value, that only we should replace with. That only we call it as key column. Next question naturally will be which variable out of this you will replace. Next question. Okay, which one will come in, which one will go out? Out of the program variable S1, S2, S3, which one will go out? And out of the decision variables X1 and X2, which one will come? Which one will enter? So for that, what is the procedure we should follow is this one. Select maximum positive NER value for maximization and circle it as key column. The corresponding variable is called as the incoming variable. So in our solution x1 we got highest 6. So that we will take it as the incoming variable. So that we are going to introduce now in our program variable. And that we call it as key column. In case of minimization, NER will take worst negative. Okay, if that is minimization. Okay, so what they are saying is out of this NER value, maximum positive value we should take as the key column, this one. Key column, and what this key column is, this only we are going to replace now. So this is the incoming variable now. But the question is next one, which one is going to go out? Which one we should replace x1 with? For that, what we should do is, we should calculate a replacement ratio. That is where we use this replacement ratio. That is a criteria, replacement ratio. How do you calculate replacement ratio is, for this key column, this is a key column now. So divide this quantity by key column. Now I am introducing 1 unit of x1 now. Then if I introduce 1 unit of x1, then how many units of this we will produce? So how to calculate that is quantity divided by your key column coefficients. So 720 divided by 2, 720 divided by 1 is equal to 720. 780 divided by 2, how much is this 780 divided by 2? 390. Next, 320 divided by 1, 320. Why we are calculating replacement ratio? To know which program variable we should replace. For that we should calculate replacement ratio here. Now out of these three, least one, because these are the constraints now here. So according to the available resource now, what is the maximum quantity I can produce? What is the maximum? So out of this, least one only we should consider. Least one only we should produce. So what is the least one now? 320. 320. This is the key row. This we call it as key row. So this we are going to replace now. S3 we are going to replace. So that you can circle. And what is the key column? This is the key column. This is the key column. Okay. Now wherever these two are intersecting, this is called as junction element or pivot element. Okay, remember that. So we are going to replace now S3 with what? X1 in the program variable. Okay. Yes. Now we understood that. Now since we are replacing this, naturally table values will change or not. In place of S3, what will come now? X1 will come. And then what will be the profit per unit will change? Quantity. Isn't it? Quantity also will change. Yes. And decision variables also, this column, this row will values will change. And now what we should do is, earlier if you remember, our initial program values S1, S2, S3 had an unit matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, whichever we are going to take it as program variable should have unit matrix. So that is the reason what should happen is this 1 should become what? 0. This 1 should become 0 here. Because our program variable should have unit matrix. So in order to get this unit matrix, what calculations we perform now, what we should do? Okay, that is what I have written here. Next step. Compute replacement ratio. We have done quantity divided by key column elements. What we have done? Quantity divided by key column elements. Select the minimum non-negative replacement ratio. We have selected minimum non-negative. Which one is minimum non-negative? We got there 320. And identify the pivot element. What is pivot element? The junction of key row and key column. Wherever key column and key row intersect, that is called as junction element or pivot element. Done. That is also done. Yes. So in our answer, that is a pivot element we got. Now next thing is, next one more important thing is what we should do is calculate a fixed ratio. So why we are doing this fixed ratio is, as I told you earlier, unit matrix we should create. We should create unit, x1 should be unit matrix. So for that purpose only we do this. Now what you should do is calculate a fixed ratio for non-key rows. Non-key rows are in our answer. Non-key rows. This is a key row, no? S1, S2 are the non-key rows. For non-key rows, what you should calculate? Fixed ratio you should calculate. Fixed ratio you should calculate. How do you get fixed ratio? Fixed ratio is, see here, formula. Key column element divided by pivot element. Key column element divided by pivot element. Here, what is the key column element? Key column is this one, x1 only. What is the key column element here? 1. 1 divided by, what is the pivot element? Pivot element is nothing but junction element now. So divided by 1, which is 1 only. Okay, next, for S2 other non-key row, no. Key column element is 2. 2 divided by, what is the pivot element? 1, which is 2. So this is a fixed ratio. Okay, not applicable for key row. So even fixed row also we have calculated. Now, after that what we should do? See the next step. Fixed ratio also we calculated. For key row, FR is not applicable. For key row it is not applicable. Next. Determine replacement decision. That means which one should come in, which one should go out. Already we have decided key column will come in, that element. Key row will go out. For that purpose only key column and key row we have determined. Next. Now step number 5. Second and subsequent table we should now next again simplex table again one more we should prepare now. Second and subsequent table. First what we should do is fill up the program variables by the replacement decision as per the earlier table. So now we should replace S3 by what? X1. And then in place of S1 again we should fill up the variables there. Yes. Fill up the profit or cost of the program variables based on the objective function only. Again we will fill up program variables coefficients. Now update the key row by the transformation rule. Key row we should update it. So now first of all what we do is again we should prepare simplex table, revised simplex table, revised simplex table, program variable, profit per unit, quantity, decision variables, what are the decision variables? X1, X2, S1, S2, S3, right? Now our program variables S1, S2 same, but in place of S3 X1 is coming. And what is the profit per unit? This one is 0 only, this one is 0. Objective function, what is the coefficient of S1? 0, S2 0, X1 coefficient is 6. Okay, this we have filled up. Now what is the quantity value is we have to divide it by key column elements to get the quantities here. See the steps now. Next one, so I filled up the profit of the program variable based on objective function. Now update the key row by transformation rule. So what we should do is here row we should update now. Key row we should update by this transformation rule. Key row how we should present now is every element now it will undergo a change. What we have to do is previous table key row element divided by pivot element. Previous table first table key row element divided by pivot element. If you do, then you will get key row values. So here what is the key row element here? 320 divided by pivot element. Divided by pivot element. What is the pivot element? 1. So 320 by 1 will get 320 only. Okay, X1. 1 by 1 we are getting 1. Then 0 by 1. 0. 0 by 1 0. 0. 1 by 1 0. See 1 by 1 is 1, not 0, 1. So we are getting updated now 1 0 0 1. This is our key row now, revised key row. How do you get revised key row here? Steps. What is the transformation rule is? Previous table key row element divided by pivot element, junction element you should divide. I told you in a unit matrix you should create, so that one should become 1. Okay, so it is 1 only. Next, update the non-key rows now. What are the non-key rows? S1, S2. Update non-key rows by the transformation rule, previous table corresponding row element. So I told you that in the key column, Pivot element has become 1. Other two should become 0 or not to form a unit matrix. Yes, for that purpose only we will follow this. I have to make other two zeros. So how to do that is, this is the rule. Update non-key rows by the transformation rule. Previous table corresponding row element minus key row element into fixed ratio. So already fixed ratio also we have calculated. This is the purpose. To make other elements of the key column as 0, this is what we should do. So previous table values minus key row element. Which row element? Key row element we should take into fixed ratio. So this is what we should follow to calculate the values of non-key rows. Let us calculate non-key rows values now. Non-key rows values I am showing here. S1, S1. So quantity, how do you get non-key rows value? Formula, previous table value as per previous table, okay, minus corresponding key row element into fixed ratio of that row. Okay, so I will do it now for all quantity x1, x2, s1, s2, s3. Now first of all, what is the value as per previous table? As per previous table, quantity S1, what is the value? 720. X1 12100, 12100. This is value as per previous table. Now key row element into fixed ratio of this row. What is the key row element here? Correspondingly 320 into what is the fixed ratio of S1? 1. 320 into 1. Similarly X1, what is the quantity we have taken? Now X1, what is the previous table value? 1. Now key row element value is how much? For that correspondingly 1. 1 into fixed ratio is 1 only, 1 into 1. This is 320 only, this is 1. Now for say x2, this is already I have taken as per previous table. Now what is the key row element of that x2? 0. 0 into what is the fixed ratio for this row? 1. So key row correspondingly key row value into fixed ratio of that row, which is 1. So 0 into 1, 0. S1, you try now. S1, first what is the corresponding key row element? 0 into what is the fixed ratio of S1? 1. So 0 into 1 again, 0. Now next S2, S2 is 0 into 1 again, S2 also 0 into 1. S3 1 into 1 is 1. So now we have to deduct now. This minus this. So we are getting 720 minus 320 is 400. This one 1 minus 1 is 0. So I told you it will become 0 key row 2 minus 0, 2, 1, 0. And here it is minus 1. 400, 0, 2, 1, 0, minus 1. So this is what we should write. First, this is S1 values. So in S1 we should write this. Now 400, 0, 2, 1, 0, minus 1. Similarly for S2 also we should do that. Okay. S2. Value as per previous table you take, as per previous table first. Quantity how much? 780. x1, x2, x3, 21010, 21010, 21010. Now next one is minus key row element, corresponding key row element. This is corresponding key row for every column, corresponding key row element into fixed ratio of that row. So what is the key row element for x1 now? First let us take quantity. Quantity is 320. 320, corresponding key row element for that quantity column. 320 into what is the fixed ratio of S2? 2. So 320 into 2. Here 1 into 2. 1 into 2. So 2. You can see that 2 minus 2 will become 0 here. Next. Next one is 0 again. Yeah. 0 into 2. Next 3 are zeros only. 0 into 2, 0 into 2, 0 into 2. 0, 0, 0. Last one is 1. 1 into 2. It's 2. So what are the values now? This is 600, 640. So 780 minus 640 is 140. 0. 1, 0, 1, minus 2. So take that here, 140, then 0, 1, 0, 1, minus 2. Yes. Okay, now same procedure will follow. Again, replacement ratio we will calculate. Okay, before replacement ratio, first what we should do? Z value first we should take, that is objective coefficients, then C value, then NER again we will calculate. NER, all elements should be less than or equal to 0, then optimal solution is achieved. So first we should take first let us take Z value. Z is nothing but objective functions value, these are against these variables. For against this x1, x2, s1, s2, s3, what is the objective function coefficient values we should take? So that is a profit per unit. That will not change actually throughout simplex tables, it will remain same. 64000. 64000. Now C, computed value. Computed value, what is the meaning of computed value is, if I introduce one unit of each of these variables, then what is the profit I am going to lose? Because if you introduce extra units, now what will happen? Your profit will decrease here. So computed value, how to get? We should multiply profit per unit into what? X1. Profit per unit into x1, profit per unit x2. First profit per unit into x1, 0 into 0, 0 into 0, 1 into 6, summation 6. 2 into 0, 1 into 0, 0 into 0, so 0 only here. 1 into 0, 0 into 0, 0, so 0. Then 0. This is 6. Now, NER, Z minus C, 6 minus 6, 0, 4 minus 0, 4. Next, zero, this is minus 6. What is the condition for maximization? This one should be less than or equal to 0. So what that is represents here? If your NER value is less than 0, that means by introducing these units, the extra profit will be 0 or less than 0, negative. So there is no point in introducing additional units. That is the optimal solution. But if you see here, one is positive, greater than 0 here. Yes or no? Yes. So again, now what we should do? Replacement ratio. Which one should go out? Which one should come in? For that we use replacement ratio. Then we should rearrange all these values or not? Yes, same thing whatever we have done there. Okay, let's do it now. So you can see even in SA material also they might have done this. Second table also. 0, 4, 0, 0, minus 6 they got. Okay, now again we should perform this. Values. Improved solution. Third simplex table. Second simplex table is over. Second this is. Now third simplex table. For that what we should do? Key column and key row we should identify. Now earlier x1 we introduced, now what we are going to do is, which one we should introduce now? Okay. Out of this, what is the selection criteria here? Maximum positive we should take. Which one? Maximum positive. This is only key column. So this is the variable we are going to introduce now. X2 now we are going to introduce now. Which the x2 will replace which variable, which program variable now out of this? That we should decide. For that, what we should do? We should calculate a replacement ratio. Replacement ratio we should calculate. How do you get replacement ratio? Quantity divided by the elements of key column. What are the key column? This is key column. Yes. Quantity divided by elements of key column is 400 divided by 2, 200. 140 divided by 1, 140. 320 divided by 0. Okay. Even third one also you are not getting. Right. So 320 divided by so we are getting few more tables also here. So 320 divided by 0 if you do, anything divided by 0 is undefined, no? Infinite. Yes. Out of this least negative value is which one? This one. This is your key row. This is your key row. This is your key row. So what is the junction element here? Junction element is this one, pivot element. This is your pivot element. Okay. So now we decided now which one we should replace. S2 we should replace with what? S2 we should replace with X2. Okay. Yes. Before we replace, now these values also will change. For that fixed ratio we should calculate. Fixed ratio. For non-key rows are now S1 and X1. Fixed ratio is, how do you get fixed ratio? Fixed ratio is key column elements divided by pivot element. Key column elements divided by pivot element. So 2 by 1. 2 by 1 is 2. Not applicable for key row, we don't do it. Other one 0 by 1. Okay, this is 0. So 2 0 we are getting fixed ratio here. Fixed ratio 2 0. They are not showing fixed ratio here in nice material. Right. So now again what we should calculate? S2 key row will undergo a change now. This should become 0. Key row element, pivot element should be 1 only. This should be 1. Other two should become 0 now. Okay, now we should change the values. Key row value, how do you update? Which rule you should follow? Key row element divided by pivot element. No, that is junction element. You remember the rule there? If you want to transform this key row, we should divide it by what? Pivot element. Okay, fixed ratio done. Now key row, how to get values now? Key row values. Transformation rule is previous table key row element divided by pivot element. Okay. Yes. Now let us do this. Values I am talking about. New table again we should set up here. Improved simplex table. This third. Improved simplex table, third one. This is program variable, profit per unit of each one, quantity, then decision variables. Guess one. Now which one we are replacing? S2 we should replace. What is the key row here? S2 is the key row here. So this we are replacing with X2. Okay, key row values. How do we get key row values? Previous table key row elements divided by pivot element, nothing but junction element. So X2, what is the objective function coefficient? X2 objective function coefficient is 4. Now calculation should start from quantity column only. So previous table quantity column, how much? Quantity is 780. 780 divided by our key row element only, no, 780 divided by what key row element? For key row, what we are going to do, the previous key row element divided by pivot element, no? Yes. So I will show here. Key row first. That is x2. Quantity x1, x2, s1, s2, s3. What is the formula is previous table value divided by pivot element. Previous table value is for quantity 140. 140. So 140 divided by 1. It is 140 only. x1 0. Okay, 0 by 1. 0. x2 it is 1. So 1 divided by 1 only. It is 1. It should be 1 only, no? That is the objective. Unit matrix we should create now for which one? x2 we should create unit matrix in our decision variables. Done. S1. S1 is 0. 0 by 1 is 0. S2 1. 1 divided by 1. Minus 2 divided by 1. Minus 2 only, no? Yes, minus 2. So this is our key row x2 values what we should take here. Quantity how much? 140. x1 0 1 0 1 minus 2. Now non-key rows. What are the non-key rows now? S1. What about other one here? X1. Non-key rows now. These two are non-key rows values. Now how to get non-key rows values? First of all, S1, what is the profit per unit in the objective function? 0. X1 is 6. Now quantity here. How do you get this? Previous value minus fixed ratio into corresponding key row element. Now S1 previous table value. What is the previous table value of quantity? 400. Quantity 0 to 10 minus 1. 0 to 10 minus 1. Yes. Now fixed ratio. What is the fixed ratio we got for this row now? 2 into corresponding key row element. So key row element is corresponding here, it is 0. Fixed ratio is 2. So 2 into 0. Less fixed ratio into corresponding KR element. So what is the fixed ratio for S1? We got 2. So 2 into, for this, what is the corresponding key row element is 0, x1. So 0 into 2, 0. Next one, 1 into 2, 2. For quantity, first of all, for quantity we should do, no? Quantity, what is the quantity? 400. This one quantity corresponding key row is 140. 140 into 2. 280. Okay, next. 2 into key row element correspondingly 0. 2 into 0, 0. Next, x2. x2 corresponding key row value is 1. 1 into 2, 2. Then S1 corresponding key row element is 0 into fixed ratio is 2. 2 into 0, 0. Next, corresponding key row for this S2 is 1. 1 into 2, 2. S3 corresponding key row element for S3 is minus 2 into fixed ratio is 2. So minus 2 into 2 is minus 4. Okay. So 400 minus 280 is 120. 0, 0, 1, minus 2. So minus 1, minus of minus plus. So this will be 3. This is S1 value. So 120. 120, that is 0, 0. 0, 0, 1, minus 2, 3. Next, next one is x1. For x1 also we should do it. Previous table value. Again, what is the previous table value? Let's take previous table value for x1. 320, 320, 1, 0, 0, 0, 1. Okay, yes. Directly have taken here. Not here, no. Where we should take here. 320, 1, 0, 0, 0, 1. Less fixed ratio into corresponding key row element. Corresponding key row element. So fixed ratio now, go to this. For fixed ratio is 0. So corresponding element is 320. So anything if you multiply with this only, everything will be 0 only, no? Yes, because fixed ratio is 0. 0, 0, 0, 0, 0, 0. So now it will be 320, 1, 0, 0, 0, 1. Same only, no? because we have fixed the ratio 0 there. So 320 1 0 0 0 1 done. Now again objective value z, first we should take z value, objective values of decision. This will not change, every table it will remain same. That is, in the objective function these variables coefficients we should take 6 4 0 0 0. x1 coefficient is 6, x2 coefficient is 4. Now see computed value. How to get computed value? Summation of profit per unit into variables coefficients, 0 into 0 plus 0 into 4, 1 into 6, 6. Here it is 0. No. 0 into 0, 1 into 4. Yes, so 4 we are getting here. So how do you get computed value? Summation of profit per unit into coefficients of the variables here. Computed value. That is profit per unit into coefficients of this variables. Summation. Third one, 1 into 0, 0 into 4 plus 0 into 0. Minus 2 into 0, 1 into 4, yes, 4. 3 into 0, minus 2 into 4 is minus 8. Minus 8 plus 6, minus 2. This is computed value. Now NER value. Net evaluation, Z minus C. 6 minus 6, 0. 4 minus 4, 0. 0. 0 minus 4, minus 4. And this one is 0 minus of minus 2 is plus 2. So we are getting positive here. It should have been either 0 or negative. Okay. So we are able to achieve C unit by 0 0 1 0 1 0 1 0 0. So even this also now one more we should introduce. Now your mind will say that which one we should introduce now. This one also we should convert into same unit matrix on S2. Now which one we should remove? Now which one is incoming, which one is outgoing, that we should decide again. Out of this, which one we should take? Highest positive value we should take now. Which one we should take it as key column? Which one we should replace? For that key column we should take now. Which one should replace highest positive value? Which one? This one. This is key column. Okay, key row. For that we should calculate replacement ratio. How do you get replacement ratio? Quantity divided by key column elements. These are the key column elements. Quantity divided 120 divided by 3, 40. 140 divided by minus 2 is minus 70. Then 320 divided by 1, 320. Out of this least non-negative we should take. Which one? So this one. This one is your key row. This one is your key row. So this one we should replace now. S1 we should replace. So you can see that all slack variables are getting replaced. And this is the junction element. Pivot element is 3 here. Pivot element. Okay, yes. So now again one more improvement table you should prepare. NER not equal to, NER should be, must be what? As one of the variable NER is positive, solution is not optimal. Not optimal. So again we have to replace with another variable. Which one? Based on key column and key row. Okay, 0 0 minus 4 2. You can see here 0, 0, 0, minus 4, 2. So as per this again rule, key column now this is, and 40 is the key row. Least replacement ratio we should calculate, key row. So based on this again they have updated, again next table they will update here, see, fourth table. Here you can see all the values, NER values here, 0, 0, minus 2 by 3, minus 8 by 3, 0. So either 0 or negative. So what does that indicate? Even if you introduce extra units also, the profit will be either 0. If it is indicating 0, that means 0 profit. If it is negative, you will get negative profit. That is the meaning. So no one will get, no one wants negative profit. So that is the optimal solution. Even if it is 0 also, what is the meaning of that? If you introduce one unit, extra unit of that variable, you will get 0 profit. So there is no point in introducing other variables. So that is the optimal solution. I hope you understood this. So this is how we do it for which one? This is a fourth table. This is fourth simplex table. So what I am doing is directly I am copying these values. These are the values what we get, fourth one. Just take according to my format there. So again, which one we should calculate here? Fixed, we should calculate fixed ratio here. How do you get fixed ratio here? So key column element divided by your pivot element. So this one we don't do. For key row we don't calculate fixed ratio. For non-key rows only we calculate. So minus 2 divided by 3. Here 1 divided by 3. So this is the fixed ratio. Okay. So based on this only we should update the values now. Improvement table number 4. Improved table. This third table or fourth table? This fourth table. Now program variable. Now which one we have to replace? S1 we have to replace with which one? S3. So S3 remaining will be same, x2, x1. x2, x1. What is the profit per unit in the objective function for those variables? S3 obviously SAC variable will have 0. Okay, then what about x2? Same, 4, objective function 6. Now quantities we should take. Quantity and variables. What are the variables? x1, x2, s1, s2, s3. Right, this we should take now. So according to the table here I am taking, what is the quantity values is 40, 220, 280. 40. So quickly we will also try to do what is there. So how do you get this? This is the key row, no? Key row, how do you get the updated values? Previous key row element value divided by pivot element. So 120 divided by what is the pivot element here? 3. 120 divided by 3, 40. So here zero divided by 3, 0 divided by 3, 1 by 3, minus 2 by 3, and 3 by 3 is 1. So 0 by 3 is 0, 0, 1 by 3, 1 by 3, S2 is minus 2 by 3, 3 by 3 is 1. You can see same you will find here, 0, 0, 1 by 3, minus 2 by 3, 1. So we have to convert S3 into a unit matrix again. So remaining 220, 280. We'll get 220, 280. So how do you get this previous 140 minus fixed ratio? 140 minus fixed ratio is minus 2 by 3 into 320. So 140 minus 2 by 3 into 320. So this will become plus 140 plus 640 divided by 3. So this is what you should do. 140 plus, in fractions only you can do this. In fractions, better to present in fractions only. So what is the fractional value? You take LCM, then it will be 3. 420 plus 640 divided by 3. Divided by 3. 353.33 you are getting. 353.33. So this we should express in fractions only. Always, if it is possible, it is better to express that in fractions only. So yeah, or values also 353.33 also you can take here. So what is the value they have taken here? Let me see. For non-key rows, what we take? Previous one minus previous value is which one? I've taken 140. Third table previous, yes, 140 minus fixed ratio is minus 2 by 3 into key row L is 320. Yeah, they are giving 220. Yeah. First of all, what is the fixed ratio there? Minus 2 by 3 they have taken or not? Let me see. They are not showing here. Values how they got 220. Let me see. So how they got this 220? That, see, according to our steps, let us do now steps. Steps is, this is a non-key row, no? Non-key row, what is the formula there? Previous table values minus fixed ratio into corresponding key row element, no? Okay. One mistake I have done. What is the key row? I have taken 320 here. It is not 320, no. Corresponding key row, what is that? 120, no. Minus 2 by 3 into 120, this is 120. Corresponding key row element is this one only, no. So that is the reason always key row up to quantity we should draw. Okay, so 120. So minus 2 by 3 into 120 is 140, this is 40. So 140 minus into minus plus 40 into 2, 80. So 220, correct. 220. Now this one is remaining values. So 0 minus 0 minus 0 into minus 2 by 3 is 0 only. So remaining you can take as it is. So 0. So I am taking going these values only 0, 1, 2 by 3 plus 2 by 3 or minus 2 by 3 plus 2 by 3 only, minus 1 by 3 minus 1 by 3 0. These are the values we are going to get if you perform calculations steps. Next one is 280 you are going to get. How you are going to get 280? 320 minus fixed ratio is 1 by 3 into 120. This is 40. So 320 minus 40 is 280. Correct. 280. What are the corresponding values calculated? Let me take that. 1 0 1 0 minus 1 by 3 2 by 3 minus 1 by 3 2 by 3, then it is 0. So for quick calculation purpose I am taking this. It is taking time now. So now what you should do immediately, Z value should calculate, C value, then NER Z minus C. Z value is nothing but objective function values only. No, x1 is 6 4 0 0 0. C is computed value. How do you get computed value? Profit per unit into this one. 0 into 0 0. This is 1 into 6 4. This one 1 by 3 into 0 0. 2 by 3 into 4 8 by 3 plus so 0. Second one is minus 4 by 3 plus 2 by 3 into 6 is 2 by 3 into 4 is 8 by 3 plus minus 1 by 3 into 6 is minus 2. So this is minus 14 by 3. Minus 14 by 3. This one. S1 it is minus 2 by 3. So minus 1 by 3 into 0 0. 2 by 3 into 4 8 by 3 plus 8 by 3 only. No, okay, minus I have taken. Plus 8 by 3 minus 1 by 3 into 6 is minus 2. So this will be 8 minus 6 divided by 3. This will be 2 by 3. Yes. Not 14 by 3, just 2 by 3 this is. So that is the reason always it is advisable to write, okay, in your answer you should write those calculations, then you will not go wrong. Then here minus 2 by 3 into 0 0 minus 1 by 3 into 4 is minus 4 by 3 minus 4 by 3 2 by 3 plus 2 by 3 into 6 is 3 1s are 3 2s, so 4 minus 4 LCM if you take a 3 12 divided by 3, so this is 8 by 3, positive 8 by 3 you are getting, 2 by 3 8 by 3 C values, finally 0. Last one is 0, all zeros only. So now NER you can calculate, Z minus C, 6 minus 6 0, 4 minus 4 0, minus 2 by 3 minus 8 by 3 0. So we have achieved as all elements of or all values, as all values of NER less than or equal to 0, the solution is optimal. The solution is Optimum this is. Okay. Now, and what are the units you should produce now? How many units? S3 0. Okay, x2 4 units, x1 6 units you should produce. Now if you substitute in the objective function, now what is the value of objective function is now 6x1 plus 4x2. We substitute now 6 into 6 plus 4 into 4, 36 plus 16, so 52. 52 is the number of units. That is the answer. What are the values I have taken here? This is profit per unit x. I took profit per unit. What is the quantity? How many units we should produce here is corresponding values, whatever we got. S3 is whatever corresponding values we get in quantity, that we are supposed to take. So this is what happens when you are in a hurry. So x1 280, x2 220. Okay, yes, and S3 is not relevant for us. So 280 and 220, slack variable, no, that is not relevant for us. So now this, if you substitute here, we will get the value. x1 is 280, x2 is 220. So 6 into 280 plus 4 into 220, if you do, then you will get what is the profit, what is the maximum profit you will get. 280 into 6, 220 into 4, grand total, so 2560. That is the answer. You can check now. 2560. This is the maximum contribution or profit. So these are the steps, my dear students. So what are the steps here? Quickly, if you revise, step number 1 is first we should formulate equations. Now I will read this. Now you will understand this table. Okay, first you should formulate what? Equation, objective function you should formulate. Maximization or minimization. Then constraints. Okay, subject to constraints you will have. Then you should convert, this is the major one here, simplex form you should convert, standard form. You should convert inequalities into equalities. Here, what is the thing you have to do is, standard form you have to write. If you have less than or equal to type inequalities, you have to convert, if you want to convert them into equalities, you have to introduce slack variable with 0, with 1 coefficient in constraints, whereas in objective function, what is the coefficient of that slack variable will be 0. Whereas if you have a greater than or equal to in equations, then to convert them into equal, then we have to introduce a surplus variable as well as artificial variable. Surplus variable will have in objective function 0 again, but artificial variable depends on whether it is maximization or minimization. Artificial variable represents, okay, a fictitious variable which has got no quantity at all. So that one will take plus m in objective function maximization. If it is minimization, plus m. If it is maximization, it is minus m. Okay. Then this is the table, simplex table. Then here what are the variables that you should know? First you should introduce program variables. Preferably always use the slack, first take slack variables only. All the slack variables as program variables. And take the coefficients of the slack variables in the objective function. That only is your profit. In case of maximization, in case of minimization, you will have cost figures. Then what is quantities? Every constraint right hand side quantities are there, no? That you should consider there. Okay. Then variables coefficient you should write here. Then first take z value. What is z value? Z value is nothing but the coefficients in the objective functions of the variables. Right? Nothing but the profit per unit or contribution per unit. Then C value you should calculate here. What is C value? C value is nothing but if I introduce these variables, then what is the profit per unit I am going to get? If I introduce each of these variables, what is the profit per unit I am going to get? That is the meaning of C value. So this represents profit per unit. How do you get this? Summation of profit multiplied by the coefficients of the variables. Then the contribution minus the profit loss by introducing 1 unit of each one. If you deduct, then you will get net profit. NER, what we call it, Z minus C. If Z minus C values either 0 or less than 0 for maximization, then the solution is optimal. If it is minimization greater than or equal to 0, then the solution is optimal. Then you need not go further. But if that condition is not satisfied, then what we should do is, then we should introduce another decision variable. So which one we should introduce, which one we should replace? For that we should know key column and key row. Which one we should take it as key column? Out of the NER values, the maximum positive value we should take it as the key column. That one is the replacing element. And which one we should take it as key row? For key row, what we should do is we should calculate replacement ratio. How do you get replacement ratio? Quantity divided by key column elements. Quantity divided by key column elements, if you do, then you will get replacement ratio. Out of the replacement ratio, least non-negative value, that only we should take it as corresponding key row. That only we should take it as key row. So that only I am going to replace. Alright. After that, what we should do is we should update the values of now since we are replacing the S1 slack variable now, so updated values we should take. For updated values, what we should do is for key row, how do you get the updated values? That key row elements divided by pivot element if you take, then you will get updated values. For non key rows, what we should do? The previous values minus fix the ratio into corresponding key row element we should multiply, then you will know for non-key rows what is the updated values. What is the purpose of doing this calculation is unit matrix we should get. Whatever variable we are introducing, for that we should get unit matrix. That is the reason we are using these calculations. Once you do this, then you will know which one is incoming and which one is outgoing. Then again calculate, take Z value, computed value, Z minus C you calculate, and then see the condition. Right? So these are the steps for maximization. If it is minimization, then I told you that we should introduce slack variable, surplus variables and artificial variable. I have written the procedure also for minimization objective. So here we introduce surplus variables, as well as artificial variable. Both we will introduce. Okay, this you remember. And here program variables, you should start with artificial variables only, because surplus variables in constraints, what we do is we will deduct, we will subtract now. So we will have negative values. So you cannot have you cannot form unit matrix. That is the reason first program variables, in case of minimization objective, what is the difference is everything is same. Program variables you should take artificial variables. Artificial variables only you should start with as program variables. That is the difference. So in case of minimization objective, naturally you will have greater than or equal to type constraints. Whenever you have greater than or equal to, then we should introduce surplus variable as well as artificial variable. So introducing surplus variable, then constraint functions are to be rewritten and converted into equalities. However, since surplus variables when introduced as initial program violate non-negative assumption, artificial variable m of heavy costs are introduced as, and constraints and objective functions are rewritten. So I told you, no, standard form we should present. So constraints, you should introduce surplus variable minus surplus variable, then artificial variable is plus there in the constraint functions. Okay. Then standard form you will get, then you should perform according to normal steps only, whatever I have given you. So initial program commenced with artificial variables only. An artificial variable once eliminated, so what we will do is we will try to eliminate this in our calculations, so that we will get only decision variables. Right, so all steps are same idea, students. Only thing is, since minimization objective constraints will be of greater than or equal to, we will have surplus variables and artificial variables. Next step is program variables. You should take artificial variables only you should start with, like how we started with slack variables in case of maximization. Here in case of minimization we should start with artificial variables, right? So this is what we are supposed to do. So what is slack variable, surplus variable, artificial variable I have written here. Next thing is, what are the special issues in LPP? If you are aware of special issues is degeneracy case. What is degeneracy is, when you calculate replacement ratio there, if you are, there is a tie-in minimum, that is non-negative replacement ratio. So if two figures are same, minimum value is 2, you have same, there is a tie, so that situation is called as degeneracy. If there is a tie in the minimum non-negative replacement ratio, we call it as degeneracy. Next, multiple optimal solutions. When do you say that you have multiple solutions is, if our NER value, in our NER values, all program variables, okay, for all program variables, we know that our NER value must be equal to 0. But for non-program variables, if you have NER value 0, that means we have multiple solutions. For non-program variables, if you have NER value 0, that indicates that we have multiple solutions. LPP has alternative solution if in the optimal table a non-program variable has NER is equal to 0. Next, unbounded solution. When you call a solution as unbounded solution is, if all replacement ratios are negative, the replacement ratios all are negative, then the outgoing variable cannot be identified here. So in replacement ratios, if all the values are negative only, then we cannot take minimum non-negative value, no. So that is called as unbounded. So that means there is no solution at all. So these are some special issues in LPP. So the notes whatever I have given students, if you follow this, okay, and look at your CMA Institute material for maximization also, minimization also. Minimization there, artificial variable, that is the key thing. And what is the value of that? M. M represents infinity cost. M represents infinity cost. So whenever if you add something to that or deduct something from that, you will get that value only. Remember that while doing calculation of that. And in case of minimization, our NER values should have greater than or equal to 0 for optimal solution. That also you should remember. So these are the solution methods, my dear students. So here surplus variable, slack variable, artificial variable are very, very important if you want to do it solution under simplex method. So that comparison also I have given here. Slack variable, surplus variable, artificial variable. Meaning, what is the meaning of slack variable? Idle or unused resources. Surplus variable, excess amount of resources utilized. For greater than or equal to, we will use this. Artificial variable, whenever we have greater than or equal to constraints also, we will use what? Artificial variable. Yes. So when it is used also I have given. Slack variable less than or equal to inequality, we will use. Surplus variable greater than or inequality, and artificial both for greater than or equal to as well as equal to constraints, we will use artificial variable. What is the coefficient in constraints we take for this slack variable, surplus variable? For slack variable in constraints, coefficient will be 1. For surplus variables, what is the coefficient? -1. We will deduct no surplus variable. Artificial variable, it is 1 only. Artificial variable, we will take it as a1, a2, a3 like that. So +1 only. But in the objective function, what should be the coefficient of these values is slack variable will have 0 because it is idle. Surplus variables also will have what? 0 only. Profit coefficient there. And artificial variables, if it is minimization plus m, if it is maximization minus m. Okay. So should we use slack variables as initial program variables in a simplex? Yes. Slack variables are used as the starting point for initial simplex table. We'll use that only as program variables. Surplus variables we never use because coefficient is -1 over here. So unit matrix cannot be formed. That is the reason we don't take as program variables initially. Surplus variables. Artificial variables, yes, we take. Initially used but later eliminated. So presence in the optimal table, yes, helps to interpret ideal and key resources, and here artificial variable indicates no feasible solution if you have in your optimal solution. So these are your slack variable, surplus variable and artificial variables. I hope you all understood here our simplex method. Little complicated, but steps I have written nicely here, and one problem also I have done. So kindly follow that, make use of this. I am very confident that in the upcoming exam they are going to ask one question on solution. Right? So graphical method, other one is simplex method. Thank you guys.